So transforming quadratics. We're going to talk about how to know when a quadratic equation is telling you to go left, right, up, down, reflect, stretch, and compress, aka shrink. So starting off here, understanding and recalling the parent function. So y equals x squared, this guy right here, that's our parent function. So y equals x squared is our parent function. And basically your parent function is where it all begins. And if you recall when we talked about parent functions from the earlier part of the year, we said that if I plug in 0 y squared into y equals x squared, it's going to be 0, right? If I plug in 1, it's going to be 1. If I plug in 2, it's going to be 4. If I plug in 3, it's going to be 9, correct? And when I reflect across the axis of symmetry, I end up at -3, 9. I end up -2, 4. And I end up at -1, 1. And this is the makeup of my parent function. This is where it all begins. The fun starts here. This is y equals x squared, and it's the parent function. Agreed? Sounds easy enough with that so far, right? All right, so now we're going to talk about, well, what if I wanted to graph y equals x squared? So I want to graph y equals x squared. What's going to happen? Well, basically what you're doing with y equals x squared, you're saying, if I plug in 0, what do I get? So if I plug in y equals -0 squared, if I plug in y equals -1 squared, if I plug in y equals -2 squared. Exactly. I end up with 0, -1, and -2. So I have 0, and I plugged in 1, so I go to -1 on 1. I go to 2, 1, 2, 3, 4. I'm going to reflect. I'm going to reflect. And I did a horrible job on drawing. We're going to pretend that's perfect on that side. Okay. What happened to the parent function? There we go. What happened? It reflects. That's all kind of wrong. So when there's a negative in front of the quadratic, what is it going to cause it to do? Reflect over the x-axis. Do you see that? All right. So let's keep trucking. So here, we are graphing 3 things in this graphing. So we're going to start off with the parent function. So we're going to quickly sketch our parent function. So here's our y equals x squared. Now we're going to graph 2x squared. So with 2x squared, y equals 2x squared, we're asking ourselves, well, what happens when I have 2 times 0 squared? What happens if I have y equals 2 times 1 squared? What happens if I have y equals 2 times 2 squared? Well, this is still what? 0. So 0 stays the same. This equals 2. So at 1, I'm now at 2. And this equals 8. It made it thinner, right? Uh-oh. 1, 2, 3, 4. And I'm going to reflect. It made it thinner. What we call this is a vertical stretch. So it vertically stretched. Okay. Now we're going to do y equals 1/2 x squared. So if y equals 1/2 x squared, it is going to be called compressed. But let's compare what happened with the blue and the red. So to each one of these points, what happened? So at 1, when I had a 2 in front, what did I do with that 1, that value of 1? I times it by 2. What did I do with the value of 4? So what am I going to do to the values of the parent function now if I have a half in front? Exactly. So 0 times a half is still going to be, but 1 times a half is going to be 0.5. And 4 times a half is going to be 2. And what happened now? It compressed. It's called, you either can say vertical, compress, or shrink. Oh my gosh, my pen is doing a very strange thing. Now notice that these types of transformation, how they are, do they have any effect on my axis of symmetry or my vertex? No, my axis of symmetry and vertex were not affected. Okay, axis of symmetry remained at x equals 0, and vertex remained at 0, 0. It should. We talked about this in absolute values. So we have y equals x squared, and y equals x squared plus 4, and y equals x squared minus 5. So parent function, quickly get you in there so we can analyze and compare. All right, parent function done. X squared plus 4. So let's talk about what this plus 4. Is it having any effect on our x values? No, it's affecting our what values? Our y values. So this plus 4 is affecting our y values. So basically it's saying if you had y equals 0 squared plus 4, what is it going to cause the value of 0 to do? Go up 4, right? If I had y equals 1 squared plus 4, what is it calling the value of 1 to do? And that's going to make it at 5, right? Same thing with 2. If I had 2 squared plus 4, it's going to make it shift up 4 units, right? So each one of my parent function values are shifting 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, I didn't realize it until I was making these notes. And then I fixed it in my notes. And on the ones on mine. Oh. A vertical. All right, so when I add 4 to the parent function, it made it a vertical shift up, right? So what's going to happen when I subtract 5? Each one of my parent function values are going to go down 5. 1, 2, 3, 4, 5. You're here now. 1, 2, 3, 4, 5. You're here. You're here. And you are here. And so we have vertical, shift, down. If adding and subtracting to the outside of our function causes it to go up and down, what's going to happen when I work from the inside? It's going to cause us to go left and right. Hopefully this is ringing some bells from absolute value units. There's my parent function. Now we have to be mindful. So if I have y equals x plus 3 squared, what do you think that plus 3 is going to, is it affecting my x's or is it affecting my y values? It's affecting my x values, right? And so that plus 3 is wanting my x's to do what? It's not. It's not wanting it to go to the right 3. It's actually wanting to go to the left. So for example, if I took y equals 0 plus 3 squared, that's going to give me 0 equals 9, right? So 0 equals 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be there, correct? Now, if I keep doing that, well, 9 as a parent function is typically right here. And what did I do to that value of 9? It did what? It went to the left, right? It went to the left. So even though it says plus 3, what's actually happening to the values? They're shifting to the left. They're subtracting 3. So each one of these are going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, X is a liar. So it's going to cause it to go. It's a horizontal shift. Left. Okay. So if the plus 3 caused me to go to the left, what is the minus 4 going to cause me to do? Go to the right. I'm going to take every point and move it to the right. So we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then last but not least. So this would make a horizontal shift, right? Okay, so putting it all together, our quadratic equation is written in the form of this. Remember, aka our vertex form. Okay, and each one of these variables plays a role. Our k is our vertical shift. It's going to cause us to go up and down, right? The k, that's affecting your y. So you're either adding or subtracting from the y value, right? Y plus or minus your k. Does that make sense? Okay. Your h is your horizontal shift. You're going to either be going left or right. So it's affecting our x. Back here. So it's our x plus or minus our h value. A is the stretch or shrink factor. It affects your y. So it's your A times your y. And if A is negative, that just means you are reflecting. So your y's become negative. Okay? If you were to graph this transformation from a table, you would always follow PEMDAS, which means that I would multiply my y's before I add or subtract. Remember that? We multiply before we add or subtract. All right, so let's see if we're good. So we're going to describe the following transformations on the y equals x. So in order to describe, you have to be able to identify what's your A, what's your H, and what's your K. So for the first example, what is our A? A is -1. Because A is -1, we know that this is a what? Reflection over the x-axis. Good job. Okay. Here, H. H equals what? H equals -2. And that's because that lets us know that it's going to go left 2. That's because H is actually a negative. So it goes left 2. And our K is -1. And that lets us know it's doing what? Down 2 units. Your K is telling you you're up and down. Your H is telling you you're left and right. And your A tells you reflect, stretch, or shrink. I wrote 2. I meant 1. You didn't see anything. What are you talking about? It was the one that got weird. All right. Let's try the next one. So we have A, H, K. What's our A? And what is this telling us? Look at your little summary above. What is it telling you? It's a shrink. So it's a vertical shrink by half. It's a vertical shrink because it's between 0 and 1, right? What is our H? 1. What does that tell us? Right 1. What is our K? 0. And that means no change, right? It didn't go up, it didn't go down. Yeah. All right, 7. So A, H, K. What is our A? Our A is 2, good. And what does that mean? It's a what? If it was negative, it would be a reflection. But is it negative? It's perfect. It's a stretch. It's a vertical stretch. Our H in this case is? Our H is 0. There is nothing within parentheses, right? So H is 0. So you can go on. And our K is 1, which tells us we went up 1 unit. Still cool? All right. We have A, H, K. All right, our A tells us equals -3. And what does that tell us? It's a reflection and what else? It's a stretch. Because the 3 itself, the absolute value of it is greater than 1. Okay? Yeah, you could be a reflection and a stretch. And that's because the absolute value of your A is greater than 1. The negative lets us know the reflection. Our H here is, and that tells us what? Right, 4 units. And our K is, and that tells us up 2 units. Do you feel like you could confidently describe the transformation from the equation? It takes practice, but you just got to remember what each variable plays. All right, so now we're going to go backwards. So now we're given words and we have to create the equation, okay? Remember the equation is y equals a times x minus h squared plus k. So the first thing we have to do is identify each variable from what we read. So we got to identify what the a is, what the h is, and what the k is. So shift left 4 units. So that lets us know that our h, because it's going to the left, that's h, is -4. And up 1 unit, it says up, that lets us know it's our k, is 1. And if no instructions about stretching or shrinking or reflecting is given, that means your a equals 1. So we plug it all in. We have y equals 1 times x minus -4 squared plus 1. So y equals x plus 4 squared plus 1. And that's our equation. Cool? Yeah, that's what you're doing. You're writing the equation. You're identifying and writing. So we're going backwards. Cool? Yes? Ready to try another one? All right. So we're going to identify the A, the H, and the K. What is the A here? 5. What is the H here? It's just 6. And what is the K? 2. Plug everything in. Y equals 5, which is my A, times x minus 6, which is my H, plus 2, which is my K. Read, identify, plug in. Read, identify, plug in. Okay? A equals, H equals, K equals. Okay, what is our A equal? Because it says reflect, right? It has to be a -1. Now, if it also said a stretch or a shrink value, then it would be negative that number. Did we go left or right? Nope. And we went down 5, so that makes it A. So we plug it all in. Y equals -1, x minus 0 squared minus 5. That would be an okay answer. It's not the most concise, concise answer would be y equals negative x squared minus 5. All right. Here, we have a shrink by a factor of 1/3. We reflect across the x-axis. We shift right 7 units and down 3 units. So our A is 1/3, but is it just positive 1/3? It's negative 1/3 because of that reflect piece, right? Our H equals 7, good. And our K equals, perfect. Oh, I forgot my negative, thank you. So y equals negative 1/3 x minus 7 minus 3. Not terrible, right? All right, let's try this. So if you want to shift, so we have the equation, y equals x plus 2 squared minus 1, up 4 units and left 2 units. What would the new equation be? So I'm currently here, and I want to change, I want to go up 4 units. So which value is that affecting? So my h is currently negative 2, and my k is currently negative 1. Up 4, which one of these am I affecting? The k. So to my k value, what do I want to do to it? I want to go up, so I want to add 4 to it, right? And then 4 units and left 2 units. So if I want to go left 2 units, what do I want to do to my h value? I want to subtract 2 from it. So what would my new h and k be? Negative 4 and 3. So I plug them in. Y equals x minus 4, negative 4. I'm just going to write it out though. Plus 3. A negative times a negative is a positive. So that would be my new home. So I identified what I already had, and then I transformed it. All right, let's do the last one. So this time we're starting at y equals x plus 3. Currently, my h equals 0, and my k equals 3. What transformations do I want to happen? Right 4 and up 2. The right 4 affects which variable? H. So what am I going to do to h? Add 4. And I want to go up 2 units. So what am I going to do to my k? Add 2. My new variables are 4 and 5. So my new equation is y equals x plus 4 squared plus 5. Huh? What did you say? Oh, yes, thank you. I didn't mean to write plus. Perfect. Y'all are awesome. And that's that. How do we feel? Good? Perfect.